All right, hey everyone, get ready because today we're doing more than just looking at code. We're actually going on a quest into a magical library. The goal? To find a secret hidden somewhere on its shelves. So yeah, let's just dive right in.
So the whole thing really boils down to this one question. You see, somewhere in this library, some of the rows of books have this special property. They're magical. Our job is to be the detective, figure out what that magic is, and then count up how many of these rows we can find.
Okay, first things first. Before we go running around, we gotta understand the layout of this place. And here's the cool part. This library isn't just about old books. The whole setup is really just a big metaphor for a data structure that, we programmers use all the time. So let's get our bearings straight.
Let's break this down into terms we know. Think of the entire bookshelf. That's our 2D array. Simple enough, right? And each shelf, well, that's just a row in the array. And every single book on that shelf is just a number inside that row. So our mission is to go through this data and count up how many of those rows are magical.
Every good quest, every good riddle has a set of rules. This one's no different. The magic here isn't just random chaos. It follows a very, very specific pattern. All we have to do is figure out what that pattern is.
And here it is, the secret to the magic. A row is considered magical if, and only if, you take all the odd numbers in that row, add them up, and the final sum is an even number. That's it. It's kind of weird, right? We're taking odd things to make an even thing. That's the key, right there.
All right, talk is cheap, theory is great and all, but let's actually see this thing in action. We've got a little map here to one specific bookshelf in this library. So let's go check it out, shelf by shelf, and see if we can spot any of this magic for ourselves.
Okay, here's our target. A pretty simple bookshelf. 3 shelves, or rows, and 2 books, or columns on each one. So our plan is to go through each of these 3 rows one by one and see if they pass our magical test.
Let's start at the top, row 1. The books we have are numbered 2 and 3. Okay, time to apply the rule we just learned.
So step 1, find the odd values. Looking at 2 and 3, the only odd number here is, well, it's just 3. That makes summing them up super easy. The sum of the odds is 3. And now for the big check. Is our sum, which is 3, an even number? Nope, not even close. So, conclusion? Row 1 is not magical. Bummer. Okay, on to the next one.
All right, let's speed through the other 2. Row 2 has 4 and 5. The only odd number is 5. Is 5 even? Nope. So not magical. And row 3, 8 and 9. The only odd one is 9. Is 9 even? Still nope. Also not magical.
So, after all that searching, we found a big fat 0. 0 magical rows on this bookshelf. Kind of disappointing, huh? But here's the thing. This wasn't a waste of time. What we just did was prove our method. We know how to check. And now that we know how, we can build a plan that'll work for any bookshelf, anywhere in this library.
Okay, so we've done our field test. Now it's time to head back to the drawing board and create a master blueprint. A solid step-by-step plan that we can use on any bookshelf, no matter if it has 2 books or 2,000.
Here's the game plan, nice and simple. First, we'll set up a counter and we'll start it at 0. Then, we're going to loop through every single row. For each row, we do that little trick, find all the odd numbers and add them up. Then we check, is that sum even? If it is, boom, we add 1 to our counter. And once we've gone through every single row, we just show the final count. That's it. It's a clean, reliable process.
All right, we've got the blueprint. Now it's time for the really cool part, turning that plan into the magic incantation, the code that's going to do all this work for us automatically. So first up, we're knocking out steps 1 and 2. See this int count equals 0? That's us creating our counter, just like we planned. And this for loop here, that's how we're going to march through the bookshelf, visiting every single row, one after the other.
Okay, so now we're inside a row. It's time for step 3, summing up the odd numbers. This block of code is where that happens. We create a temporary sum just for this row, sum odd. Then this inner loop goes through every book on the current shelf. And here's the real magic detector, that little percent sign, the modulo operator. When we check if the remainder after dividing by 2 is not 0, we're literally asking the code, hey, is this number odd? If the answer is yes, we just add it to our sum. Pretty slick.
And this is the grand finale for each row. This is where we take care of steps 4 and 5.
After we've added up all the odds, we do one last check. We use our trusty modulo operator again, but this time we're asking, is our sum odd an even number? If the answer is yes, jackpot, we found a magical row, and we add 1 to our main count.
So after the code has gone through every shelf, checked every book, and done all those checks, the loops are all done. The very last thing it does is return that final count. And just like that, our quest is complete. We've got our answer.
So what was the real treasure we found in this library? It wasn't just the answer. It was this problem-solving spell book that you can use for pretty much anything. The big takeaways are, first, break down those big, scary problems into tiny, manageable steps. Second, always test your logic with a simple example before you even think about coding. Seriously, it'll save you so much grief. Then you can translate that plan into code. And finally, don't forget that sometimes the simplest tools, like our little modulo operator, are the most powerful ones you have.
Okay, so now you know the secrets of the library, but I've got one last riddle for you. What if the magic rule changed? What if a row was magical only if the product of its odd numbers, multiplying them together, was an even number? How would you have to change your plan? What part of the code would need a rewrite? It's something to think about. Anyway, thanks for coming along on this coding quest with me.